morning, students. So yesterday class will continue. So video number 6, class number 6. And yesterday one problem I explained. Intersection of two equivalence relation is always equivalence relation. Intersection of two equivalence relations is always equivalence relations. So next problem, the union of two equivalence relations on set A is not necessarily an equivalence relation on the set. And this problem, only example we have to give. So what is said that A equal to 1, 2, 3. Okay, I am taking set A 1, 2, 3. Let R and S be two equivalence relations. Let R and S be two equivalence relations. On A, that is R is equal to 1, 1, 2, 2, 3, 3 and 1, 2, 2, 1. So this relation is equivalence relation because and this relation are in all the three conditions are reflexive, symmetric and transitive. So reflexive is 1, 1, 2, 2, 3, 3 reflexive. Symmetric A comma B, B comma A 1, 1, 2, 2, 3, 3, 1, 2, 2, 1, 2, 1, 1, 2. Now this is you will have to check on transitive 1, 1, 1, 2, 1, 2, 1, 2, 2, 1, 1, 1, 2, 2, 2, 1, 2, 1. So this R is equivalence relation and S equal to 1, 1, 2, 2, 3, 3 and 2, 3, 3, 2. So one more equivalence relation I am taking. Both R and S are equivalence relations. Even this also equivalence, this also equivalence. Both are equivalence relations. My question: intersection is always equivalence relation. Yesterday I have proved. Now today union is not equivalence relation. But if R union S, okay, R union S, 1 comma 1, 2 comma 2, 3 comma 3, 1 comma 2, 2 comma 1, 2 comma 3, 3 comma 2. So this is called union or union S. Or union S. But you see whether it is union of two equivalence relation is equivalence relation or not. So R union S, you have to check whether the reflexive is there or symmetric is there or transitive is there. So with all the three conditions it must be equivalence relation. But what he is telling, so this is not equivalence relation. So you check whether which condition is not satisfied. So 1, 1, 2, 2, 3, 3, 1, 2. So 1, 1, 2, 2, 3, 3. So set is 1, 2, 3. 1, 1, 2, 2, 3. This is a reflexive. Symmetric you check. 1, 1 reverse 1, 1, 2, 2, 3, 3, 1, 2, 2, 1, 2, 1, 1, 2, 2, 3, 3, 2. This is symmetric also. Now it is present, reflexive is satisfied, symmetric also is satisfied. Now check transitive whether it is satisfied. 1, 1, 1, 2, 1, 2 is there. 2, 2, 2, 1, 2, 1 is there. 2, 2, 2, 3, 2, 3 is there. 3, 3, 3, 2, 3, 2 is there. 1, 2, 2, 1, 1, 1 is there. So 1, 2, 2, 3. What is the answer? 1, 3. Yes, 1 comma 2 belongs to R union S, and 2 comma 3 belongs to R union S. So transitive check. It is differential symmetry, but transitive you have to check. Transitive means how many order pairs you are taking? 2 order pair. Where? In union, because I want union is equivalence relation. Not already. Already it is these two are equivalence relation. But we have to prove union. In the union, you have to select 2 order pairs. 1 comma 2 belongs to R union S, and 2 comma 3 belongs to R union S. But 1 comma 3 does not belongs to R union S. Therefore, R union, that is R union S, is not transitive. R union S is not transitive. Therefore, R union S is not equivalence relation. Not equivalence relation on okay. So sometimes the question, intersection of 2 unions is equivalence relation. So again we have to prove union is not equivalence. Give an example. So I given one example. Both two R and S are equivalence relation on setting. I am taking union, but union 2 are the satisfied, one reflexive is satisfied and symmetric is satisfied, but transitive is not satisfied. When not transitive, so this is not R union S is not transitive, and it is not equivalence relation. Okay, sometimes so, but usually union is not necessary. Okay? So next problem, equivalence class. Equivalence class. So this is also important definition. What is the equivalence class? R is equivalence relation only. R is equivalence relation on a non-empty set A, on a non-empty set A, on a non-empty set A, and one element belongs to A. What is our equivalence relation? What is A? It is a non-empty set. And what is small a? This is the element belongs to set A. So what equivalence class is denoted by? Suppose when cos it, equivalence class of A is denoted by this symbol. Just like it is greatest integer, but it is not greatest integer. It is called equivalence class. So equivalence class is defined as x comma x belongs to A. X belongs to A. Some element you have to select. So x comma A belongs to R. Suppose for example A value 1, 2, 3 is there. 1 belongs to A, but 1 comma A must be belongs to R. So what is this? That is x related to A. So this is the equivalence class's definition. What is the equivalence class? If R is an equivalence relation on a non-empty set A. If R is an equivalence relation on a non-empty set A and A belongs to A, the set X belongs to A such that X comma A belongs to R. That is X related to A is called the equivalence class of A and it is denoted by this. Now, equivalence class of A, x belongs to A such that x comma A belongs to R. What is this? That is x related to A. So this is the definition of equivalence class. And most important, sometimes that in the problems show that the relation R is equivalence relation and find the equivalence class of 1, equivalence class of 2, equivalence class of 3, even sometimes equivalence class of elements of set. Okay? So repeating, my dear students, this is very important. Even the JEE advanced main level their questions comes equivalent class. So this textbook is not given correctly. It is if R is an equivalence relation on a non-empty set A and A belongs to A, the set X is called equivalence class of A and it is denoted by this. But be careful, not confuse it, it is not greatest integer. Okay? So it is the equivalent class of A. X belongs to A. So you have to remember this formula, be careful. So practice when perfect. Okay? So just you have to remember. Suppose you do not remember this formula, so it is very difficult to find equivalent class. Okay? To practice again and again. So x belongs to A such that x comma A belongs to R. That is, it is nothing but x is related to A. So I will give you one problem. So you get, I guess, okay? What is the equivalent class? But equivalent class, it must be a set only, not in ordered pairs. Okay? It is a defined set. Okay? So one example I will explain. So what is let A equal to 1, 2, 3, 4. It is a set A 1, 2, 3, 4. Consider the equivalence. Consider the equivalence relation. Are equal. But he is given equivalence relation. What is given? 1, 1, 2, 2, 3, 3, 4, 4. Is the compulsory? It is a reflection. No. 1, 2, 1 comma 2, 2 comma 1. This is equivalence relation, but equivalence class means the relation R must be equivalence relation. Suppose the equivalence is not there, no equivalence class. When it is equivalence class, R must be equivalence relation. Okay? So what is the problem? I have given A 1, 2, 3, 4, 4 elements I have given. Consider the equivalence relation. This is a relation on set A. Okay? This is a relation. This is satisfied, reflection, symmetric, and transitive. This is a relation, the equivalence relation. Which is given in the problems, it is given the equivalence relation also. Otherwise, some problems you have to prove that equivalence relation and also find the equivalence class. Okay? Okay. On A, find the equivalence class. Find the equivalence class. Find the equivalence class of the elements of the elements of the sector or elements of EA. This is the problem. So what is the problem? It is given set A and given equivalence relation on A, but is asking find the equivalence class all the 4 elements. Sometimes find the equivalence class 1, find the equivalence class 2, find the equivalence class of 3, find the equivalence class of 4. He is asking all the 4 elements. Okay. What is equivalence class 1, 2, 3? Okay. Now solution. So already it is equivalence class. What is A? A equal to, be carefully, 1, 2, 3, 4, and R is equal to 1, 1, 2, 2, 3, 3, 4, 4, then 1, 2 and 2, 1. This is the equivalence relation on cycling. Now what is the next? The equivalence class of A or B. Okay, one by one. What is the generally equivalence class formula? X belongs to A such that X comma A belongs to R. So X is given. This is the definition I given. So these are all he is asking equivalence class of set A. Now what is the equivalence class of 1? He is asking equivalence class of set A. So how many equivalence class of, you will get 4, 1, but he is asking directly 1, 2, 3, 4. What is equivalence class 1? This is, what is X? 1 belongs to A. X is belongs to A. So what is 1 comma A? Okay. X belongs to A. X comma 1 belongs to R. Equal. Now you start one way. 1 comma 1 must be belongs to R. So these are called A only. These are called A. He is asking X comma 1 must be belongs to R. No? You have to substitute X is 1. X is 1 means what is the answer? 1 comma 1. Is there 1 comma 1? Yes. But it must be settled. Be carefully. But is the 1 comma 1 is there or not? Okay? 1 comma 1 is there or not? 1 comma 1. Okay? Next, equivalence of 2. X belongs to A. X comma 2 belongs to R. Okay? This is only one set. Even you have to check not only this one, equivalence class of set is asking. Okay? What is the equivalence class of 1? 1 comma X is 1. 1 comma 1. X is 2. 2 comma 1. So I think it is 2 is counts. He is asking equivalence class of set A. Equivalence class of set A. So I'll start repeating once again. Equivalence class of 1 means X is 1, 1 comma 1. Okay. X is 2, 2 comma 1. X is 3, 3 comma 1 is not there. X is 4, 4 comma 1 is not there. Only 1 comma 1. So 1 comma 1. So answer is comes 1 comma 1 and 2 comma 1. So equivalence class of 1 is 1 comma 2. Equivalence class of set. Then what is next? Equivalence class of 2. X is 1, 1 comma 2. Yes. X is 2, 2 comma 2. Yes. X is 3, 3 comma 2. No. X is 4, 4 comma 2. No. I think this also equivalence class of 2 is 1 comma 2. Then what is next? equivalence class of 3, x belongs to A, x comma 3 belongs to R. Now we start. A is there, no? What is A here? A equal to 1, 2, 3, 4. Okay. A is 1, 2. Now we start equivalence class of 3. Okay. 1 comma 3. No. X is 2, 2 comma 3. No. X is 3, 3 comma 3. So 3 is there. X is 4, 4 comma 3. No. This is only 1. Okay. Then what is the next? 4. Equivalence class of 4. X belongs to A. So x comma 4 belongs to R. Now what is x is 1? You start 1 comma 4. I think 1 comma 4 is there? No. 2 is there? No. Only 4. So what is the answer? 4. This is called equivalence class. So, but he is asking not individual elements, he is asking equivalence class of elements of setting. But he is asking equivalence class 1, 2, 3, 4. Okay? So these are the answers. What is this is? Equivalence of 1, this is 2, this is 3. So these are equivalent class of 1, 2, 3, 4. Write the equivalent class of setting. Sometimes equivalent class of 1 means this is answer 1 comma 2. Only 2 is asking 1 comma 2 only. He is asking 3 means 4 means 4. So this is the most important problem. The name is called equivalence class. Everybody know what is the equivalence class is defined? Equivalence class is defined as x belongs to A. What is x? You know, it is elements of setting. So that x comma A belongs to R. So all the elements you have to check. Suppose x is 1. So A is equal to 1 comma 2. Now x is 1, but is asking 1. What is the equivalent class of 1? So 1 equivalence class also is equivalent class relation, equivalence relation. You have to write equivalent relation, but this is elements in setting. But this x comma A belongs to R. It must be belongs to R. That is called equivalence class. Now next some tricks, shortcut methods that one must propose. What is number of subsets? That not very important. The total number of subsets of A cross B is 2 to the power mn. Total number of subsets of A cross B is 2 to the power mn. What is n? Number of elements of set A. What is n? Number of elements of set B. So this is total number of subsets of A cross B. What is the formula? 2 to the power mn. What is m? Number of elements of set A. What is n? Number of elements of set B. So total number of subset of A equals to total. Next, total number of relations. Total number of relations from A to B is 2 to the power mn. Whatever the subset of A cross B known is same as number of relations from it. What is the number of relations from set A to set B? Is the total number of relations from set A to set B is equal to total number of subsets of A cross B. Subset of A cross B is also known as number of relations from A to B. Number of relations from A to B is 2 to the power mn. What is the m? Number of elements subset A. N is called number of elements subset B. Okay. Another total number of relations from A to E. Only one set, but here two sets are there. From A to E is 2 to the power n square, even m square. For example, set A is 1, 2, 3. Write the number of relation from set A to set A. From set A only, and it is understood. A to M is only one set. So what is n here? N is 3. So what is the total number? Total number of relation 2 to the power 2 is 2 to the power 3. So what is the answer? 8. N is 3. N square, no? N square means it is 9. 2 to the power 9. 2 to the power 9 is number of relation from set A to set A. From A to E. But here two sets A and B. Here also two sets. Here only one set 2 to the power n square, or even you write 2 to the power m square. No problem. Okay. Now one more important total number of relations. Total number of relations from total number of reflexive relations from A to A means from A is 2 to the power n into n minus 1. So this is a CET point. Sometime in JEE main, or it is sometime in advance, or in CET the question is about CET problem. Even one mark question also, but this is not one. But in theory these three are there. But this is the CET point only. Even these three, first three, even they will ask one mark question. And total number of relation from set A is asking, and this also possibilities there. This also possibilities. But this is number of reflexive relation from A to A, 2 to the power n into n minus 1. What is n? Number of elements in the set A. Okay. So what is one more? Total number of symmetric relations from A to A is 2 to the power n into n plus 1 by 2. This is also there. So you don't ask how it is comes, but it's format there against it is not necessary. So in CET means it's within 1 minute you want answer, no. Again you have to put in between. So 2 to the power n into n minus 1, 2 to the power n into n plus 1 by 2. These are most important questions. Sometimes they ask that one mark questions. Okay. So number problems no need, because here what is m, what is n, you have to multiply. Here also what is m, here what is n. These three, first two sets A and B, and the last three only A set from A to A. So these are important points. You have to remember. Points to remember. Okay. So almost equivalence class the relation chapter is over. So next we'll start functions. One more problem I'll explain. This is the last problem. This is the last problem. Let R be the relation. R be the relation defined. Let R be a relation defined on the set R, on the set R of real numbers, defined by R equal to A comma B, so that 1 plus AB is positive. Determine whether the relation R is reflexive, symmetric, or transitive. Okay. This is the question. This is the last problem. So, how many periods are over? Now it is 6 classes I have finished the relations. Then next chapter is function will be there. Equalities. When you are asking, but relations, even maybe sometimes 3 marks is asking many times, but sometimes is asking 5 marks question also. So this is the last problem. So R be the relation defined on the set R of real numbers defined by R equal to A comma B such that 1 plus AB is positive. Determine whether the relation R is reflexive, symmetric and transitive. Okay. So you check whether it is reflexive is there, symmetric is there, or transitive is there. So what is the important conditions? Reflexive, symmetric and transitive. So one will start. What is the R is defined? R is defined A comma B such that 1 plus AB is positive. It must be positive. So what is the first one? Is reflexive. I have repeat once reflexive. So reflexive, you have to select one element. Please remember, it's very important. Both easy with answers, but elements lay 9. But we have to prove A comma A. Suppose A comma A, 1, 1 comma 1. That's simple. But in symmetric, one ordered pair is given. You have to prove one more ordered pair. It's reverse. In transitive, 2 ordered pairs. Okay, you have to prove one more ordered pair. But here, what is the you are choosing for A belongs to R, real number. Here both R is a relation, R is a real number, R to R. So A belongs to R is a real number. Okay, a real number. So 1 plus, it implies 1 plus A into A. 1 plus A square is positive. 1 plus A into A equal to 1 plus A square is positive. That is A comma A belongs to R. Therefore, R is a reflection on R. But in CT or even a JEE main is asking this question. It's very important. Okay? 1 plus AB is greater than 0 means you have to remember the answer. Now it is reflexive status because 1 plus A square always positive. No negative answer. It's a positive quantity. So it is always a reflexive. Okay? Now what is the next one? Symmetric. Okay? Symmetric. Symmetric. How many elements? 2 elements. A comma B belongs to a real number. How many order pairs are given? 1 order pair. What is the order pair? A comma B belongs to R. It is given. It is given means what is the condition? 1 plus AB is positive is given. 1 plus AB is positive. Then we have to prove B comma E belongs to R. 1 plus AB is same as 1 plus BA. AB is same as BA. So this is also positive. I am interchanging. When 1 plus AB means 1 BA is. Therefore it is B comma A belongs to R. Therefore R is symmetric. R is symmetric on R. Then what is next? Then let me check whether it transitive or not. Now third one, transitive. Okay? Transitive. Transitive, whether it is satisfied or not. Transitive usually students are taking 1 plus AB is positive and 1 plus BC is positive, then 1 plus AC is positive. Hence it is transitive. Oh, it is. But these are orally, you know that. Reflexive, symmetric, even you know that. But it is very difficult to calculate. 1 plus AB is positive, 1 plus BC is positive, 1 plus AC is positive means what? Okay. So we have to know maybe it is not transitive. You check how to check this transitivity there. We have to select 3 numbers. Now what are 3 numbers? For 1 by 2 minus 1 belongs to R. I am taking 3 numbers. 1 comma 1 by 2 belongs to R because 1 plus 1 by 2 equal to 3 by 2, it is the positive answer. 1 comma 1 by 2 belongs to R, 1 plus 1 by 2, 3 by 2, 3 by 2 is positive. Is a positive. And 1 by 2 comma minus 1. A comma B, B comma C. A comma B, B comma C belongs to R. This is also belongs to R, whether it is positive or not. So 1 minus 1 by 2, 1 by 2. This is also positive. 1 comma 1 by 2 belongs to R. 1 by 2 minus 1 belongs to R. Both are positive. Okay. But 1 comma minus 1 does not belongs to R. Why? Because substituting 1 minus 1 is 0 greater than 0 is not true. 0 greater than 0 is not true. So what is the answer? 1 comma 1 does not belong to R because 1 minus 1 0 0 greater is not true. Therefore R is not transitive on R. Hence the relation R is reflexive, symmetric, but not transitive. So good problem and interesting also. So in the JEE main, even I told CET or not main and CET and main, this question is asking. So even sometimes one, I don't know here, but this question is asked in previous year. Okay. So what is the problem? R equal to 1 a comma b such that 1 plus ab. Suddenly our question already solved it, you know. 1 plus ab is positive. So which condition is satisfied? Reflexive, symmetric, but not symmetric. 1 plus ab is positive. 1 plus ab is positive, reflexive, symmetric, but not transient. So, and next class we'll start another chapter. The name is function. Even that functions already you know that in first year. What is the function? So this function even relation also is there in first year. Even function also is there, but relation basic. What is the relation? What is the domain? What is the range? Even inverse relation also is there. But here function also you see first year syllabus only. So what you thought in first year, what is the function? Domain, codomain, range. Domain, codomain, range. But in relation are only domain and range. But here domain, codomain and range will comes. And this is continue next class. Okay? It's functions. Next week, next video, we'll start this function.